Get started in about a minute. All right, quick notes. Some of you checking your grades see that you have an F because you did not take the test. I still don't have a test from Julia, Nathan, Grayson, Jenna, Lucia. Donovan, I got yours. Priscilla, I got yours. Olivia, you know the deal. You're going to fix it. And Hannah, I don't have a test. Winter, I can't remember. Did you send it to me or not? I know you didn't send it to me as an assignment, but if you send it to me in chat, that's fine, or email. I right now I show you as not having turned in, but I'll check if you sent me an email or not. Sometimes you send me emails instead of attaching it, but for right now, if I called your name out, with the exception of Donovan, Priscilla, and Olivia, you said you were going to fix it. If I called your name out, you need to fix this because you got F's right now, 0, right? That's bad. So let's fix that. The test was last Wednesday. It's almost Wednesday, a week later. Some of you haven't even attempted to take your test. That's crazy. I should let that F stand. That's crazy. Take your test. All right, homework. We'll get started right now. Homework. Any questions on the homework? All right, I'm gonna have to look at your graphs, right? So I can call out the answers to questions 1 through 4, but 5 through what, 9 were to make a graph. So questions number 1 is 5 p.m. Question number 2 is 9 a.m. Question number 3 is 4 p.m. to 5 p.m. and question number 4 is 7 p.m. to 8 p.m. All right, and the rest were you had to make graphs. So hopefully your graphs look good. I will check those all. And we're moving on. All right, so here's our calendar. So we're gonna do this week. Now you notice tomorrow it says review. I have to give the 10th graders their PSAT test tomorrow. So I will not have class tomorrow, meaning that I will have a review sheet. It'll just be on sections 12.1 through 12.3. It won't be long. It'll be a 10, 15-minute worksheet, that sort of thing. I'll have it posted by 7:30 in the morning. So there will not be a physical class video tomorrow, but there will be an assignment, just a review. And then we'll jump back in, finish 12.45 and then 6A. And that brings us, we should be live, like we'll physically face-to-face on Monday. Hopefully you all come back. And then 7th graders, they're taking their CMAS that day. You guys are going to be taking it Tuesday, Wednesday. So no class there, or at least math class there. And then believe it or not, that's the first week of May. So there's only 4 weeks in May. And here's 2 of them right here. We'll finish chapter 12. We probably are not going to get through all of chapter 13, the last chapter of the book, but we will get through most of it. So chapter 13 will be on the semester final, but more than likely we won't be able to finish chapter 13, but that the material will be on the semester that I actually cover. I won't put anything that I don't cover on the test. The second to last week of, meaning the week that would be below this one that's posted right here, that week, Monday, Tuesday, I'll do normal class, and then Wednesday, Thursday, Friday, semester final review. And then that last week is just like it was at Christmas time, where you come in, you take 1 to 2 tests. It's half day every day. You go home, and then we have the last day of school for those of you that are absent or had appointments for makeup day. So you won't be coming to school on that final Friday. All right, here's your homework for tonight. For those of you that are curious, yes, there are buttons on your calculator that will do everything that I'm going to show you today. If you want to Google it, search it, and find it, by all means. If you want to come back on Monday and ask me to show you where it is on your calculator, I will show it to you. It's probably a pretty good thing to know where it is on your calculator. You also need to do it by hand, so this will not be a calculator test. So you will have to do all this by hand, but the kid that knows how to do it on their calculator is getting ahead of the game here. Potentially on CMAS, they may ask you, one of these questions. And if you know how to use your calculator to find the answer, boy, does it speed things up. All right, here we go. Oh, I like this. This is a fun class, statistical measures. All right, statistical measures. Remember I said that the two main things as adults, regardless of whatever your job is, whether it involves math or doesn't involve math, the two main things in math that you use as an adult is basic arithmetic, add, subtract, multiply, and divide, and statistics, right? And today you're going to see some very commonly used statistics. Do you read bar graphs? Sure. Do you make bar graphs? Probably not. But what we're doing today, lots of people do. All right, quick review. Remember, we're talking about in this entire chapter data. Data is plural as well, too. And these are facts about objects. They could be numerical. They may not be numerical. Hey, what's your favorite color is a non-numerical piece of data about you. How tall you are is a numerical piece of data about you. We gather data and we turn them into statistics. I want to find what are all the heights of all the kids in my class. Those would be called a statistic. Right? To interpret statistics, we take the data and we make graphs because nobody likes to look at simply a table of numbers. And this entire chapter is about that process, the process of taking those numbers and being able to tease out information about those numbers without just looking at the numbers in a table. One of the primary methods we have is making graphs. Today, we will not be making graphs. We will be using another method for gaining information about data. This is statistical analysis. All right, this chapter, we already done bar graphs. We already did line graphs. Not today. I believe this is Wednesday's class. But on Wednesday, tomorrow is Wednesday. Thursday's class. Thursday, we'll do stem and leaf plots for those who've never done them. Then we're going to move on to box and whiskers and finally histograms. Some of you have never done those last three, stem and leaf, box and whiskers, and histograms. So those will all be new. We will do a much slower class than what we did for bar graphs and line graphs, which you have done before. Today, we're doing none of that. We're doing another statistical analysis tool. Remember, we take data, and data we would like to have some order from that chaos of numbers, right? And that would be arranging the data, right? Primary method we have is we make a graph from that data. But there's another method, and it's called statistical measures. If arranging the data and you draw a picture is called graphing, this is a calculation. So we're going to literally take arithmetic, add, subtract, multiply, and divide, and somehow gather information by simply doing a little bit of math. All right, and the reason we do this is it allows us to draw conclusions, all right, or to answer questions about the data itself. So we got a bunch of definitions today. Grab a piece of paper, let's write these down. First one is called statistical measures, big fancy word. And this is the arrangement of data to allow for interpretation or conclusions. So statistical measures. We have 4 of these statistical measures that we will use. Last year you learned, I think, 3 of these. We get the 4th one this year. The 4 statistical measures that we will be using today are called the range, the mean, the median, and the mode. Yes, I'm going to pause so you can write all this down. It turns out that 3 of these 4, the last 3, the ones that start with the letter M, right, are called measures of central tendency. In other words, it is a measurement where you find the middle of the data. That's why it's called central tendency. Where does the middle tend to be? And the first one, the one that doesn't start with an M, it tells you something about the spread of the data. Now, I will explain all of this to you. I just need you to copy down what's here on this slide right here. So today we'll be doing statistical measures. That's the name of the section. We will be calculating the range, the mean, the median, and the mode. And this will be a calculation, literally a calculation. And I did say that there are buttons on your calculators that will do all of this. You just need to know where those buttons are. Now, I will not be showing you those buttons. You can figure that out on yourself. I will be showing you how to do it without a calculator's help. In other words, instead of pressing the mean button on your calculator, you're going to be doing it by hand. Now, some of you already can probably do 1 or maybe even remember 2 of these, but most of you don't remember how to do 4 of these. In fact, we never even saw 4 last year. We saw 3 of these. Last year, we saw the mean, the median, and the mode. We do not see range. Some of you may have it. Our book chooses not to teach range until the 8th grade. All right, for those of you online, are we okay to move on, or do you need more time to write this stuff down? The issue for most 8th graders is that every one of these, range, mean, median, mode, are all 4 of them are easy. Sometimes it's hard to keep these track in your head, like which means which. And so having a good resource card come test day is imperative to not making a silly mistake of calculating median when you needed to calculate mean. All right, we're going to do these one at a time. And I'm going to choose to start off with, from top to bottom, range. Also in your notes, range is the difference. Difference, fancy word for subtraction. A difference between the greatest and the smallest number. Well, if difference means subtraction, we are literally going to take the largest data point and subtract the smallest data point, literally. So I'm going to have data, and it's going to be numerical data, by the way, not non-numerical. You can't subtract red from blue, that sort of thing. But I'm going to take some data. I'm going to have a biggest number and a smallest number. So, for instance, the biggest number might be 50. The smallest number might be 30. Literally, to calculate the range, you simply subtract those two. Now, I don't need a calculator to do this, right? To find out that the range was 20. All right, I'm going to hold off on explaining why you would need range until later on in the class. But for right now, the calculation of range is you find the biggest number, smallest number, subtract. It is that easy. Remember, we said that range would also tell us the spread of the data, how spread apart the data is. In other words, how much is it to go from the smallest to the biggest, or from the biggest to the smallest? It's 20. All right, we good? To do this calculation, no big deal. They will give you a data set. There's a data set right there, and then we'll say, what is the range of the data set? So the hardest thing is simply not to make a silly mistake. You must find the largest, you must find the smallest number of the data set. So as I go down those numbers, it doesn't matter which one you start with. I'm going to find the smallest one. It looks like the smallest one is 11, and the biggest one is, well, they're right next to each other, 65. So 65 is the largest, 11 is your smallest. To calculate the range, you simply subtract those two numbers. Is it literally that easy? It is literally that easy. 65 minus 11 is 54. So the range of that data set is 54. In other words, there are 54 numbers between the smallest and the largest. I'm not sure how many of these we need to do because it's pretty simple, but a quick note, range is never a negative number, even when the numbers are negative. Notice all the numbers are negative now. So let's see, the biggest number here is negative 11. The smallest number here is negative 65. So when you subtract negative 65 from negative 11, when you subtract negative 65 from negative 11, two negatives make a positive, well, you're still going to get 54. So it doesn't matter whether the numbers are positive or negative. Range will always be positive. The other measures could be negative, but this one will always be a positive number. Biggest minus smallest, done. Okay. Range can be 0, right? If you had a, let's imagine everyone by the end of June, everyone had their birthday, and I asked everyone, how old are you? Well, then everyone would have the same age. And, you get what I'm saying. Jace, you're the outlier. But when you did your subtraction, you would get 0. And 0 can be your range. All right, I don't want to do too many of these. Range is literally that simple. When an 8th grader makes a mistake on this, it's because they go a little bit too fast and they literally can't find the smallest and the biggest number. So you got to do a little bit of hunting, right? So let's see, 39, nope, 33. I'm trying to find the biggest. 77 is pretty big. Ooh, 94 is the biggest number. So the biggest number is 94. The smallest number, was it 39? No, it's 33. 33. So I subtract from the biggest the smallest, and we get our answer, 61. Okay, so what is this good for? I said I was going to hold off on that explanation. So sometimes, let's just say I gave 2 classes a test, right? I got Class A and Class B. These are their scores. So if I were to compare Class A to Class B, these are all the scores they had on the test, some A's, some B's, some F's, that sort of thing. Why would I want to calculate the range? Well, I'm going to do the calculation for you real quick. So Class A, look, somebody got a 99, almost 100. Class B, there's a couple of A's thrown in there, but not many, well, 95. So if I do that calculation for the range, I just did it there for you, we find that the two classes, one had a range of 47 and one had a range of 32. So what you can draw from this conclusion is this. In Class A, I mean, there's a big difference between the person that scored the highest and the person that scored the lowest. 47, that's huge. Somebody really didn't do so hot, right? 47, 99 minus 47, right, would be their score. On class number B, their scores are a bit closer together. Not a lot, but a bit. We would like, if these were test scores, we would like the range to be as small as possible. And that would indicate that the class as a whole did roughly the same. Now, that can be bad if the average score was an F, but the range was 10. Okay, well, everybody scored about the same, but everybody failed the test. Okay, so you need some more information than just range. But range will tell you how spread apart the data is. And generally speaking, specifically in this case, we would like the range to be as small as possible because that would indicate that everyone learned basically the same stuff. And then you can get some, hey, did the kids learn the stuff very well? Did they learn it very poorly? That sort of thing. If everybody gets an A, the range could be less than 10. And that would indicate that you did a very, very good job, both the kids and the teacher. So as a teacher, I always look at the range when I give a test. I want the range to be a small number. There are times when you want the range to be a large number, but this is not one of them. All right. So range, we use range to tell if the data is spread out or close together. And most of the time, I want my data to be pretty close together. I would like everyone to get either an A, a B, or, rare cases, a C. So let's see, the range between 100 and the lowest B would be 20 points. So I don't want my range to be 40 points. I would like my range to be about 20 points every time I give a test. Doesn't always happen that way, but I would like that. Okay, any questions on range, the easiest one? All right. Now you got to be careful though, even though range, we like the numbers to be small. Here are two data sets. Notice I got really big numbers on the left, really small numbers on the right. And when you calculate the range, they both have a range of 54. I mean, both data sets from biggest to smallest. But when the numbers are very large, right, having a range of a 54 would be very different than when the numbers are very small. Notice if those were test scores and 54 was perfect, right, on set 2, somebody got an A and somebody got 0 points. So just because the range is small, right, you need to also understand what the numbers were in your data set. On set number 1, boy, did those scores they're all roughly the same, right? Even though the range is 54, they're all about 49,000. And that would be a very good thing if you wanted your numbers close together. Whereas on set number 2, having that range of 54 is actually, well, actually it's a bad thing. Set number 2, what do? Remember, we subtract the biggest from the small, or the smallest from the biggest. So on set number 2, 54 minus 0 is 54. Whoever asked that question. Okay. So let's see, we just did range. Let's move on to mean. All right, so the last three, the ones that start with an M, remember I said they were measures of central tendency. They basically state where the middle of the data is, where the middle of the data. Okay, so the first one we're going to do is literally called the mean. And I always use that picture because this is the one that when you're doing this by hand, boy, do you not want to calculate the mean. But unfortunately, you do. It's the meanest one. And it's because you got to do a whole bunch of addition and you got to do some division. With a calculator, this is no big deal. But doing it by hand, the mean is the meanest one. So that's how I always remember. What typically happens is students can't remember which one is mean and which one's median because they both start with an ME. So mean is the one, it's called the average. You got to be careful. average can mean two things. Your average could be your median as well too. So, but in general usage, when someone says what is the average, they're talking about the mean. All right, so it's the average of the data. Find the mean of the data set. What do? You take all the numbers, you add them up, and you divide by how many numbers you get. So for those of you that can't recall how to do the mean, well, there are your steps. Step number one, add up all the numbers. That's why this one's mean is. We're going to add all those numbers up. Step number two, we divide not by any random number. We divide by how many numbers we get. So let's see. Let's count numbers. Let's see. There's 1, 2, 3, 4, 5, 6, 7, 8, 9. There are 9 numbers. So we got to do the mean calculation here. We got to add up all of those numbers and divide by 9. Through the magic of math, I will do that for you. All right. So I add up all those numbers. I get 299. And that's what I have to divide by 9. So I'm skipping the mean part. The mean part is doing this by hand is a pain in the butt. Right? It's definitely addition and it's long division all thrown in together. Yes, you will get a decimal answer. Yes, many times you have to round. Yes, you can get a repeating decimal. Okay. Sometimes this number, look, we got an answer of 33.2. That's the middle of the data. Sometimes the number will be in the data set, but notice this time there's no 33 even. There's certainly not a 33.2. So when you calculate the mean, rarely is the number in the data set. I mean, like 33.2 is one of the numbers. It can happen, but rarely does that ever happen. For instance, your GPA, your grade point average, is a mean. They take all your scores, add them up, and divide by how many scores there were. That's how you find your grade point average. All right, that is the mean, the meanest one. All right, a quick note, and I just made this actually. The answer, like the answer you get from mean, it might be one of the numbers in the data set, but it also might not be. It's rare, rarely is that the case, but sometimes it can happen. All right. Boy, if you give a bunch of numbers, I mean, you can have a data set of 100 numbers, and they'll say, what's the mean of it? Absolutely positively, this is where you want to find the mean button on your calculator. Like, calculator, do this work for me. But, oh, by the way, you got to type in still 100 numbers. But yes, there is a mean button on your calculator. All right, rounding might be necessary. I believe tonight for homework, let me flip and see. What does it say? It says round to the nearest tenth if necessary for tonight for homework. All right, so I have this one for practice. Remember, we're going to add up all the numbers. So add up all those numbers. Let's see, can we do this by hand? Really easy. Let's try. Trying it by hand. 1 plus 5, 6, 10, 19, 27, 39. So 9, carry your 3. 3 plus 3 is 6, 9, 16, 21, 24, 28, 37, 41, 49. So I'm getting 499. Let's see what the book says. Oh, look at me. I can add. I hope so. So unfortunately now we got to take 49 and divide it by, is there 9 numbers? 1, 2, 3, 4, 5, 6, 7, 8, 9. We do. Let's see, 499, and we're going to round to the nearest tenth. 499 and divide by 9. Let's see, 9 goes into 49, 5 times 45. Subtract 49. 9 goes into 49, 5 times 45. I need to add a 0. So decimal place, add a 0. 9 goes into 40, 4 times 0.4. It gives me a 36. So we're getting a repeating decimal here, 40. So 0.44, so 55.4. All right, so I did that one really quickly, but you can kind of get the feel and the flavor for how that one's done. All right. 55.4, that is the mean. Notice there is no 55.4 in my data set. In fact, the closest number is what, 51? Or is there, I got a 60? No, I mean, this number is pretty far from any number in my data set. But if we were to say, hey, what's the average? If these were test scores and we said, hey, what's the average in the class? It's not very good, right? 55.4. All right, so let's go back to that one data set. So these, I mean, I literally took this two class. I think this might have been you guys, the two. No, that's not right. What did I have two of last year? I forget. But anyway, I had two of one class, and I simply was it Algebra 1? I think it was. I had two Algebra 1 classes, and I simply took their scores and I wrote them up. So these are actually real scores. Let's see, Class A, if we were doing the mean through the magic of answers, here are the two means. Add them all up, divide by how many numbers. So let's see, what can we see about this? Notice, looks like both classes had roughly the same score, right? The average of the two classes. So even though Class A had, look, there's a 99, right? Almost a perfect paper. And the highest grade in Class B was only a 95, that their means ended up being exactly, 98, 78.9 and 78.4 is basically the same number. So what can you grasp from this? It looks like the average score was a C plus. If we include the range in this data, remember the range for Class A was larger than it was for Class B, but for the most part, using the mean here, we can say that the students learned as equally as well in both classes, even though we had some more A's in Class A. Class B actually scored, even though their mean's slightly lower, but it looks like, in order to make up for those higher scores, that they had some more average scores. Class A also, I think, had the lowest score, right? 52. And there you go. That's how you would use mean. Boy, is that a big but. And the big but is this. Look at these two data sets. Set number one, looks like we got a whole bunch of 3-digit numbers and one single digit number. Set number two, well, it's the same numbers. Notice, literally, it's the same numbers, and I got one very large number. If we were to do the averages, the mean of both of these data sets, right? The one with the small number and the one with the large number, look what happens. These are called outliers. And when you do the average, what happens is if you have a very large number, it drags your average way super high. If you have a very low number, it drags your average way super low. The average, if we were to do the mean for both of these, it would give us the false indication of what the average was in their data set. Yeah, I mean, the averages, you can do the mathematical calculation, but those outliers will really, it's called skewing the data. It drags that mean in the wrong direction of what the data is actually about. So when you have these things called outliers, when you calculate the mean, it leads you to the wrong conclusions. Okay, so if mean is the average, we only use means when there are no outliers. If you look at your data set, tonight for homework, it's not going to say, should I use the mean or median, right? It's going to say, calculate the mean, calculate the median. But if you are looking at a data set and you have an outlier, we define an outlier, at least in 8th grade, as a number that is way different than all the other numbers, right? If everybody gets somewhere between a high, like even an F, like say a 55 and 100, and then somebody scores a 2 on it, right? If you have an outlier in your data, you don't ever calculate the mean, right? It's going to skew the data. So we have another thing that we can use when you have outliers, and it's called the median. Now, it doesn't say use the median when you have outliers. Sorry, it just simply says the median is the middle number. Okay, median is the middle number. But what's nice about the median is it doesn't matter if you have outliers. It gets rid of outliers, and you'll see why here in a second. So median is the middle number. If the mean is the one that's the meanest, the median is the one that's kind of cool, kind of fun. No calculations are necessary. Well, I take that back. There's one calculation occasionally necessary, but even that calculation is pretty simple. All right, so let's everybody okay? Let's just see how the median is calculated. So here's what you got to do. This is the hardest part of the median. Step number one is they give you the data set, but you got to put the number. You have to put the numbers from least to greatest. Notice our numbers are not from least to greatest. So this is the hardest thing. So you got to take all the numbers, least to greatest. So 11 is the smallest, so I write 11. What's the next biggest number? 14. So I write a 14. What's the next biggest number? 19. I write a 19. I put the numbers, see what I'm doing here, and I'm also crossing them out as I go through them. The crossing them out will keep yourself straight. What's the next biggest number? Is it 27? I think so, 27. If there's a mistake to be made, it's when you're putting the numbers from least to greatest. You skip a number or you don't put them in the right order. The next biggest number is 32. And I'm going to stop with my writing with my finger and I'm going to make it look nice and pretty. But that's the process that I would use. I would write them from least to greatest. You see what I did? And like I said, when I'm writing them from least to greatest, I'm crossing things out. As I write down a number, I write down 11, cross it out. Write down 14, cross it out. Okay. Now I have the numbers from least to greatest. Now I'm going to find the middle number. Literally, the middle number. What number is in the middle? So how do you do that? Here's the process. I'm not looking at the data set anymore. I'm looking at the numbers from least to greatest. I'm going to cross out the smallest and the biggest. And then I'm going to cross out the smallest and the biggest. In other words, one off the left, one off the right, one off the left, one off the right. They happen in pairs, so cross off the smallest and the biggest. Cross off the smallest and biggest. You will continue this process until you get down. Look, I'm at the middle number. So the median literally is 32. Is there any math involved? Well, okay, you got to put the numbers from least to greatest. But the actual process is just crossing out numbers until you get to the middle number. Cool, the median's 32. Notice if we had had an outlier, for instance, if that wasn't a 11, that was a 0, we would have gotten rid of the outliers on the first step with that first cross out. If you had a 4 million, right, you would have gotten rid of that 4 million on the first cross out. So medians are what you use when you have outliers in your data set. Okay. When you have an odd number of numbers, boy, does this work out great. Look, we're only left with one number because there's an even number on the left and an even number on the right. When you have an odd number of numbers, this works out wonderfully, right? Wonderfully. So let's find the median of these numbers. Here are the numbers. I write them from least to greatest. Yes, I use the same one. I just changed some numbers around. Okay, I have all the numbers written from least to greatest. Now that will take you some time. Got the numbers written from least to greatest. Once that's done, I cross off the smallest and the biggest. Smallest, you see what I'm doing? Smallest and the biggest. Smallest and the, oh, we got a problem. This is what happens when you have an even number of numbers. When you have an even number of numbers, eventually you can't, if you cross them out, you're left with no number. So when you have an even number of numbers, well, you're going to be left with two numbers, and now we're going to do the average. In other words, we're going to do the mean of these two numbers. Not the mean of all the numbers, but the mean of the middle two numbers. In other words, I take the middle two numbers, add them up and divide by 2. So I take the middle two numbers, add them up and divide by 2. And we get to our median, 35 point, add these two up, divide by 2. I'm skipping the division step here, but that's the process. This is what happens when you have an even number of numbers. So when an odd number of numbers, you'll always, once you do the cross out, you'll be left with one number. When you have an even number, you'll be left with two numbers. Just add those two up and divide by 2. All right, quick notes. Well, I just said that. This is very easy to screw up. Usually the screw up happens when you're not crossing out numbers from the original data set and you like leave a number off or something like that. All right, so let's do this whole process by hand here, Let's see. Step number 1, we got to write them from least to greatest. Smallest number is 39. Nope, it's 33. So I'm going to write a 33. Comma, the next biggest number is at 39. Look, I got two of those, so 2 39s. So 39, and you do write repeats, so 39, 39. Next one, I believe, is 40. What's the next one? Is it 45? I'm looking, yep, 45. If you forget to cross out a number, you can make a silly mistake. Next one, is it 51? Yep, 51. This is the only part that takes a while just getting this done. Is it 77? Yep, 77. And then 8194. 8194. Okay. Now, I would recommend that you do one quick check step. Count how many numbers you got here. 1, 2, 3, 4, 5, 6, 7, 8, 9. I got 9 numbers. 1, 2, 3, 4, 5, 6, 7, 8, 9. Very good. All right. Hey, and notice we have an odd number. We like odd. We don't like even. Cross out the smallest, cross out the biggest. These happen in pairs. Cross out the smallest, cross out the biggest, cross out the smallest, cross out the biggest, cross out the smallest, cross out the biggest. 45 is your median. This can be done pretty quickly as long as the data set only has, in this case, 9 numbers. If it has 90 numbers, you're going to be spending some time doing this by hand, or you're going to find the median button on your calculator. All right, any questions? I'll do it nice and pretty here now. Any questions on what I did? Any questions on what I did? All right, most of you should remember doing that last year. I don't know, medians are kind of fun. All right, notice we don't really have any outliers in our data set here. So when we do the median, notice, okay, we got a little bit bigger of a difference here. The median was 80.5 and the median on the data set number 2 was 77. So what does that mean? Well, that means that there are more numbers that are larger than there are smaller for Class A. For Class B, notice that since the median is smaller, that must mean that there must be more lower scores to pull that number to a little bit lower of a number. And that's in general words. Those aren't mathematical words I was using right there. But notice that the median is higher for Class A. That means there's more people with higher scores than there are for Class B. That doesn't necessarily mean the medians are still pretty good numbers. But remember, when we did the mean, we basically got a high B as the average. Now, when we do the median, well, since we have a median of 80.5, one of two things happen, right? It certainly doesn't mean that the lowest number isn't pretty low in Class A. It is. It's a 52, but it simply means we got more numbers because all you're doing is crossing them out. Well, that just means there's more numbers that are larger or higher to that perfect score of 100 in Class Set A. I always, and by the way, the grade book that I have that we use here at school does this. Every test I give you will provide me with the mean. It calculates for it automatically. Provides me with the mean and the median. So I always look at both of those numbers. And usually, if there aren't outliers, the mean and the median should be pretty close together. Remember, we got a 78 as our mean for both of those numbers. And now it looks like Class B, the mean and the median are pretty darn close. They're only one off from each other. Class A, they are a little bit more spread out. Okay, remember the reason why we use median in the first place is when we have outliers. Notice if these numbers, these are not from least to greatest, but if they were, right, if they were in least to greatest, when you cross out the top and the bottom, notice you immediately get rid of your outliers. So that's why we use median rather than mean when you have outliers, because it immediately gets rid of your outliers, okay? Immediately gets rid of your outliers. There is a better mathematical definition of outliers, but unless you take a statistics course, then we generally just describe outlier as a number that's either too big or too large for your data set. All right, median is what you're going to use when you do have outliers. And like I said, tonight for homework, it does not say to pick and choose between the mean and the median. It tells you what to do. Okay, we're running through these pretty quickly. Let's see, we did range, we did mean, we got median, we got one left, right? Mode. Mode is the most used number or item in the data set. Most used number or item in the data set. When would you use mode? Well, let's say you guys ever been on shopping for shoes online, right? Anybody know the most common size of women's shoes or men's shoes, right? And that would be mode. Hey, what's the most of the number that they buy from, right? I don't know what it is for men, 10, 10 and a half, 9 and a half, or something like that. No idea for women, but that would be an example of a mode. If I ask you, what's your favorite number, right? Pick your favorite number. And I did the class, what's everyone's favorite number? That would be the mode. Whichever one you had the most of. Oops, sorry. The most used number or item in a data set. So when is it important to use a mode? Well, if that's what your question is about, right? And it's really dependent, right? Would I do a mode on a test scores? Oh, absolutely not, right? Because I don't care. There could be 4 Fs that scored a 59, or there could be 4 95s. All that just means a bunch of people scored the same score. But if I'm looking for, like the shoe one is the best example there. If I'm looking for, hey, what kind of shoes do I need to build if I have a factory? Well, I better build a lot of the most common shoe that's ordered, right? If a medium is the most common size of T-shirt, then I better have a whole bunch of mediums that I'm ready to sell. All right, it is darn simple to find the mode of a data set. You simply look at the numbers and you see which one is repeated the most. So 14, hey, there's 2 14s. Anything else? Any other number? Oh, no, it's 3 14s. There's 3 14s. So the mode is 14. Now, here's some notes about mode. You may have a mode, you may not have a mode. And you can also have more than one mode. Remember, mode is the most common number, one that's used the most. So if you have 2 numbers that are repeated twice, then you could have 2 modes. You can either have 0 modes, no number is repeated. You can have 1 mode, or you can have multiple modes. So it's not just the numbers that are repeated, it's the numbers that are repeated the most. Okay. So what's the mode here? Let's see. 14 repeated, nope. 32 repeated, nope. 65, nope. 11, nope. 30. Are there any numbers repeated? Look, there are no numbers repeated. So when no numbers are repeated, we say no mode. No mode. Guys are being awfully quiet today. Any questions? All right, you can have or not have a mode. You can have multiple modes as well too. If there are 2 numbers that are repeated the exact same number of times and it's the most, then you can have multiple modes. All right, so once again, mode, what number repeated? Be careful. I mean, yes, this is done literally just with your eyeballs, but you can certainly use little marks. Hey, that's repeated. That's repeated. Sorry, why are you not writing? That's repeated. That's repeated. Any other number? 33? Nope. 77? Nope. I mean, I already see the answer, but you get what I'm saying. I mean, put little tick marks next to the ones that are being repeated. But sometimes you'll get modes where you get 2 39s, but you get 3, for instance, 94s or something like that. So it's not just the numbers are repeated, it's the one that's repeated the most. Well, let's do the mode of our last one. Like I said, I don't know if I would consider the mode for our data set between the 2 tests, if that's relevant, but it looks like I had a bunch of 91s and a bunch of 77s. And like I said, this is more coincidence than anything on a test thing. When I would never use a mode for test data. Because it doesn't really tell me much other than, I guess, on a negative sense, hey, if somebody was cheating, then you have the same score of the person sitting next to you type thing. Maybe I might use it for something like that. But not in the sense of telling me something about the data. Just because there were multiple people that scored a 91, well, I'm happy, right? That doesn't mean that there are more A's and just because the mode appears, right? Yeah, that's all I wanted to say about that. All right, so mode is you simply tell the most commonly used number, and that's kind of it for everything. We did the mode, we did the range, not a measure of central tendency, just a measurement of spread. And then we did the 3 measures of central tendency, and that's median, mean, and mode. Mean is the meanest one because it requires the most actual calculation. Median requires you to put them from least to greatest and then cross things out. Remember, if you have an even number of numbers, the middle 2 numbers, you add together, divide by 2. Mode, you simply calculate, or you simply indicate which number is being repeated. Range is the biggest number minus the smallest number. And that's it. So let's see, 1 through 10, questions 1 through 10 are literally the instructions say find the range, median, and mode of the data sets. So you're just beginning doing this calculation a bunch of times. Don't be surprised if some of them do not have a mode, right? Some of them have a mode, some of them don't have a mode. So if there's no mode, you just put none or no mode. All right, any questions on anything I did today? David, you feeling confident?
Yeah.
Yeah, pretty easy. And for those of you that are interested, I highly encourage you to, Google the name of your calculator, the model number, and just, do like mean or median, and you can figure out where those buttons are. You can still mess it up with a calculator because when there's 8 or 9 or 10 data points, you're going to have to enter in those data points into your calculator as well too. So you can fat finger your calculator even though the calculator is doing the heavy lifting. All right. If there's any questions, send me a chat or an email. I'll be happy to answer it if you need any help on any of this. Remember, tomorrow is just going to be a worksheet, so there's no actual class tomorrow, but there will be work for you because I got to do the PSAT test with 10th graders, and then I will see you guys on Thursday. You guys have a wonderful day.